Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going over metals and alloys. Now, if you haven't already watched my video on metallic bonding, I would thoroughly recommend you watch that first before proceeding with this video. If you have already watched it, please don't forget to give this video a thumbs up, subscribe to the channel, tell everyone about it, grab a pen, grab some paper, and let's go ahead and jump in. Okay, so some key information first of all. Metals have giant structures with strong metallic bonding. Metals and alloys have high melting points. An alloy is a mixture of a metal with other elements. So for example, a common alloy that you've probably all heard of is steel, and that is a mixture of iron and carbon, which we'll go into a little bit later on in the video. Metals are too soft for most purposes, so are made into alloys to make them harder. Now, this is a concept a lot of people don't realise. They often think of metals that are very strong and used in construction, and that is very true, but they are alloyed with something else to make them harder. Most metals are actually relatively easy to bend and are quite malleable, so we need to make them harder by turning them into alloys. Okay, so let's have a look at the metal versus alloy structure. And just to remind you again, if you haven't yet seen my video on metallic bonding, I would really recommend you watch that first before carrying on with this section. Okay, so just to remind you then, the structure of the metal is shown on the left just over here. Now, remember, the structure of a metal is that you have layers of positive metal ions, kind of in these rows and columns in this giant lattice structure, and you've got these delocalized electrons surrounding it, causing the metallic structure to come together and be bonded. Now, if you imagine kind of like a force coming in at this exact point, hopefully we would realize that all of these ions would shift across in this direction. And so this is why metals are quite malleable, because when you put a force into a certain area of the metal, because they're all lined up together, it means that all of that those ions can move together. So for example, what would be drawn out if we just draw it down slowly here? We'd have 1, 2, 3 at the bottom, and then we would force those other ones across like that. So the layers can slide essentially. Now, in an alloy, as we said briefly at the start, you put in a different elements, or sometimes a compound, it can be as well. But the point is you disrupt this layered structure. And so now when you put a different sized element within the metal, you now make a mixture. And hopefully we can see the structure of that alloy now is now known as distorted. So we do not have these rows or these columns anymore. It's not nice and neatly compacted as in a metal. And so that means when you apply a force, you might only move one of those ions, but you can't move all of them together, and it makes these metals much, much stronger. Okay, so the question then is, why are alloys harder / stronger than metals? Now, I've kind of just briefly explained that in the last slide, so if you want to have a go at answering this before I go for the answer, please pause the video now, or if you want to just get down this really common question, then feel free to take the notes now. So why are alloys harder / stronger than metals? So I'd probably start off with just saying alloys are a mixture of a metal with another element. Okay. So then what's going to happen? So different sized elements are added into the structure. This distorts the structure, and the important bit is that so layers cannot slide. And then just to make that really obvious, making alloys harder. Perfect. Don't need an S there. Harder full stop. Okay, so I'd say the really important parts here are the different sized elements are added, distorts the structure, and the layers cannot slide. That is your key content there for why are alloys harder or stronger than metals. Okay, so now we're going to go on to a section that is for triple only. So these are some examples of alloys. So according to the specification, you need to be able to recall a specific use for each alloy, and you need to be able to interpret and evaluate the composition and the use of each alloy given appropriate information. Now, essentially what that means is I think you're likely to be given some information in an exam. You're likely to be given a table with different alloy properties within it, and then you'd have to write about the different properties. You might have to match a property to a use case in the everyday world. So it's a really good idea to be able to have some of your own information, your own knowledge on this topic, should you be able to have to write about it in an exam. Okay, so the first thing we're going to look at then is brass and bronze. So bronze is an alloy of copper and tin. And remember, you do need to know this for your GCSE. Brass is an alloy of copper and zinc. They both have low reactivity and they're resistant to corrosion. And so that's why you often have bronze statues out, when you go to visit cities or towns, you'll find statues of kind of famous people, and they're often made out of bronze, and that's because they can survive being out in the weather, whereas a stone statue eventually gets worn away because of the acid rain. So bronze statues are a lot more expensive, they're a lot more durable. Another example here of brass would be like a brass band. So tends to be a little bit more shiny than bronze, but again, quite resistant to corrosion, lasts a long time, can still be bent into shape and things, but it's much harder than normal metals, and so it can cope with kind of the constant use of musical instruments, and obviously, again, resistant to corrosion and things like that. Gold. So gold is used for jewellery. Normally alloyed with silver, copper and zinc, and so it's rare that you would get kind of pure gold. Now pure gold is what's known as 24 karat gold, so the proportion of gold is measured in carats, 24 being 100% and 18 being 75%. Now the way they work this out is really, really simple. So essentially you just measure it out of 24. So if you have 24 over 24, that's 100%. And then to work out as 75%, you would have 18 over 24, and that equals 75% once you times it by 100. And so pure gold is often not used for jewellery because it's too malleable. Those layers can slide too easily. And so they alloy it with silver, copper and zinc to distort those layers, to stop the layers from sliding. Now, you may have to do a calculation in your exam to work out either something like, what is the percentage of gold in 16 carats, so it'd be 16 over 24, or it might be the other way around, and they might say, something like, what is the carats of 30% purity of gold, or something like that. So just be aware you might have to rearrange this equation for your exam. Okay, steel then. So steels are alloys of iron with different amounts of carbon. So high carbon steels are strong but brittle. Low carbon steels are softer and easier to shape. So for example, this might be used in something like construction. So you'd use this in building bridges. If you've ever had a house extension, they often have to put a steel lintel in to support the house up. So that's the kind of steel that would be used there. Whereas low carbon steel would be something that's easier to shape but still strong. And so this would be in things like car manufacturing and stuff like that. So if you imagine a car being crumpled in a crash, they have to design it so that the car absorbs that impact. They still want to make it out of something strong, so steel, but they use low amounts of carbon to make that steel more malleable so that the car can crumple. Now the last type of steel that you've probably heard of is stainless steel, just down here, and these are the examples just on the side here. So a stainless steel is added in with chromium and nickel, and these make them resistant to corrosion, and it also makes them kind of nice and shiny as well. Lastly, aluminium. So these alloys are low in density and resistant to corrosion, so they're really lightweight. And so that means they're often used in things like aircraft or sports equipment, or for example here in alloys, because it makes them lighter, stronger, and therefore you reduce the amount of fuel you need to use, but they've still got the strength. Thank you very much for listening. please do go through my other videos in order to go through more GCSE science content. And remember, if you ever need help with any GCSE science, Dr. Kyle explains. Thanks very much. Bye-bye.